All today's topic is marginal probability density function for a continuous random variable. The first problem, find the marginal density function. So f of x comma y, it is given in the question. So first we need to find, it is asked with respect to x and y. First I will find for x marginal density function of x. What is the formula for this? So it is f of x, fx of x we can write it, or f of x, simply f of x you write it. It's not wrong. So what is the formula? Limit of y, f of x comma y dy. So I will get f of x. So limit of y is nothing but 0 to 1. F of x comma y, it is given in the question. 2 by 5, 2x plus 5y into dy. Integrate it. 2 by 5. With respect to y, we have to integrate it. 2xy plus 5y square divided by 2. Limit is between 0 to 1. Substitute upper limit and lower limit. Lower limit 0, only upper limit I have to substitute. 1, with respect to which variable you have to substitute? At y only you have to substitute. X you have to keep it as it is. So 2x plus y only I have to substitute 2. So 5 by 2. Simplify this or leave it as it is. So 2 I will take LCM, I will simplify it, it is easy for me. So 2 by 5, 2 I will take it LCM, so that I have taken outside. So when I take LCM, 4x plus 5, so it is nothing but answer f of x is 4x plus 5 divided by 5 is my answer. So completed. You have to write with the limit. Now write the limit of x. Then only it is completed. Marginal density function of x, this is the way we have to do it. Same way, marginal density function of y. Same procedure, only you have to change the formula. So now, when I do it, same way fy of y equal to f of y. So limit x, f of x comma y dx. Okay. So now limit is carried with respect to x. So it is 0 to 1. F of x comma y, it is given in the question. Into dx. Integrate it. By 5. 2x squared by 2 plus 5xy. Substitute here upper limit and lower limit. Remember, you have to substitute it only for x. Y you should not substitute. 2 get cancelled. Substitute means 1. 1 plus 5. Okay, x is 1. So 1 plus 5 y. So what is our answer? F of y is nothing but 1 plus 5y into 2 by 5 into 2 by 5. Limit, with limit you have to write, y limit you have to write is an r equal to 1. So complete. So we'll do one more problem. Very simple. This is very simple. Same way simple. One more problem I'll do in this itself. So this is our second problem. If the joint density function of x and y is given to be Sum of function of x comma y equal to e to the power minus x plus y, where x is greater than or equal to 0 and y is greater than or equal to 0, 0 elsewhere. Find marginal density function of x and y. Find the marginal density function x and y. I will give you one more subdivision. Probability of x is less than 1. Okay. So how to do in this case? Okay. So first marginal density function. First I will calculate marginal density function. So use the formula density function of x. So when I do use it, so we know that now only we have seen the formula. So same concept only. Marginal density function of x is nothing but fx of x. It's nothing but f of x integral over y f of x comma y dy. Every time write the formula, then only you have to do whatever the calculation. F of x is nothing but now limit of y. Y limit is 0 to infinity. 0 to infinity. F of x is given to be e to the power minus x plus y into dy. Okay, minus x plus y into dy. Integrate it. So when I integrate it, you can before integration you split into two terms. So it is easy for my substitution. E to the power minus x you write, into e to the power minus y you write, into dy you write. E to the power minus x, it's like a constant. We will take it outside. E to the power minus x we need not do at all. Okay, before integration I will take it outside. Now e to the power y dy. So integrate it. E to the power minus x as it is outside. E to the power minus y, it's minus y divided by minus 1 divided by minus 1, 0 to infinity. When I substitute upper limit, e to the power minus infinity 0, e to the power 0 1, lower limit is 1. So infinity, lower limit already minus symbol, minus minus plus, so e to the power minus x, I will be having e to the power minus x only. Answer is e to the power minus x. Okay, now take the answer and you write e to the power minus x, write the x limit. X limit is given to be x greater than or equal to 0. So completed. Marginal density function of x completed. Okay. So same concept, we have to do it for y. So now go with y. So when I do y, marginal density function of y. So fy of y equal to f of y, limit extending to f of x comma y into dx. So f of y equal to 0 to infinity e to the power minus x e to the power minus y into, we have to write dx. Okay, e to the power minus y is constant, 0 to infinity e to the power minus x into dx. I can integrate it, e to the power minus y constant. So integration when you do e to the power minus x divided by minus 1, 0 to infinity. When I substitute upper limit and lower limit, I will be getting e to the power minus y. So take the answer and write. So f of y is nothing but e to the power minus y. So y greater than or equal to 0. So completed. So one more subdivision it is asked. Whatever subdivision, it is very easy only. Our second subdivision, probability of x is less than 1, it's given. So less than 1 means how we always, it's less means that is your upper limit, greater means that is your lower limit. So now less means upper limit is 1. So lower limit, fix it from the question. So x limit you have to fix. X lower limit is 0. 0 to 1. F of x dx. F of x dx is the normal procedure. So f of x now only we have calculated. F of x is e to the power. F of x is nothing but this is our f of x. So it is nothing but 0 to 1 e to the power minus x dx. Integrate it, you get your answer. E to the power minus x, when I integrate it, minus 1, 0 to 1. Substitute your upper limit and lower limit. When I substitute the first upper limit, so minus of e to the power minus 1, lower middle minus minus plus 1. So answer will be 1 minus 1 by e, or take a LCM. So e minus 1 divided by e. Okay. So our answer is, final answer, probability of x is less than 1. It's nothing but e minus 1 divided by e is our answer. Thank you.